You know the feeling. The waiter drops the bill, or you're staring down the clock in a high-stakes exam, and suddenly, kuch samaj nahi aata. Your mind just goes blank. You freeze. High-speed mental calculation relies on highly structured visual and algorithmic systems. These methods transform numbers from abstract concepts into manageable patterns. The problem begins with how we're taught in school. Traditional math forces us to calculate from right to left. This contradicts how we naturally read and process information from left to right, creating an unnecessary mental bottleneck. Instead of reaching for a pen, you can use friendly numbers, figures that end in 0. If you need to multiply 49 by 6, round 49 up to 50. 50 times 6 is 300. Then, since you added one extra 6 to make that round number, subtract 6 from 300 to get 294. This reduces the number of figures you have to hold in your working memory at once. By replacing slow, traditional methods with structural shortcuts, you begin to process calculations with the same natural flow you use for reading. It is the first step toward building a more efficient way of thinking for competitive environments. To build that calculation speed, you can take a straight visual path. Take the abacus. By physically manipulating these beads, users anchor the calculation in a tactile space before eventually transferring those movements into mental imagery. This spatial logic is the core of the Japanese multiplication method. To multiply 12 by 32, we draw diagonal lines to represent the digits. One line, a gap, and 2 lines represent 12. These intersect with 3 lines, a gap, and 2 lines for 32, creating a diamond grid. Now you simply count the points where the lines cross. Group these intersections vertically. Draw a loop around the left cluster, another around the middle clusters, and a final loop around the right cluster. These grouped intersections represent the hundreds, tens, and ones of your product. There are 3 dots on the left, 8 in the middle, and 4 on the right. When you drop those totals down, you have your answer, 384. This method makes place value visible and intuitive. However, it reaches a limit with larger digits. For a problem like 9 times 8, you would have to count 72 individual intersections, making the process slow and prone to error. Visual methods are excellent for building number sense, but for the speed required in an exam hall, you need an algorithmic upgrade. Vedic mathematics provides that upgrade. It is a system designed for rapid pattern recognition, allowing for lightning-fast mental processing without the need for drawing. Look at this Vedic 2-digit trick. To multiply 39 by 24, we stack the numbers and first multiply the straight vertical columns. 3 times 2 gives us 6 on the left. 9 times 4 gives us 36 on the right. Next, we cross-multiply the diagonals. 9 times 2 is 18, and 3 times 4 is 12. We add those sums together to get 30, which we place in the center gap between our previous results. To finish, we add the columns and carry over the extra digits from right to left. We keep the 6, carry the 3 to the middle to make 33, then carry that 3 to the left to turn the 6 into a 9. The final result is 936. While Vedic math is ancient, other systems were born from the need to survive. In the 1940s, engineer Jakow Trachtenberg was held in a Nazi concentration camp. To keep his mind occupied in this environment, he developed a base 10 speed system that functioned entirely without pen or paper. His system uses specialized rules to bypass standard multiplication tables. In his rule for 11, for example, multiplication is replaced by simply adding each digit to its neighbor on the right. Of Optry-current. Try multiplying 45 by 11 in your head using this rule. Add the 5 to its imaginary right neighbor 0 to get 5. Then add the 4 to the 5 to get 9. Finally, add the 4 to the imaginary 0 on its left. Your answer is 495. Drop a comment if you got it right. Vedic cross-multiplication and Trachtenberg's rules transform the brain into an active pattern recognition engine, prioritizing speed and accuracy over rote memorization. Armed with these techniques, you can approach an exam paper or a restaurant bill with a clear strategy. Structure replaces the typical anxiety of the blank page. True mathematical fluency is the ability to switch between these visual representations and algorithmic rules, depending on the problem you face. When you understand the reasoning behind these shortcuts, math becomes a predictable, logical landscape where every calculation follows a consistent pattern. Agar aapko ye video pasand aaye, show your support with a like. If we reach 500 likes, we'll release a deep dive into calculating square roots mentally without using a pen. Mathematics is a landscape of hidden patterns. Once you understand the grammar of those patterns,